Hi everyone, this is M.Poornima Mahalingam. Today we are going to discuss a topic about three-phase, controlled chopper DC speed control technique. So in that we are going to discuss about chopper controlled DC drive. So before going to the topic, we can see what and all we are going to discuss in this video. So introduction, DC to DC converter for DC drive, and step down chopper is a class A, step up class B, and two quadrant chopper, four quadrant chopper. These are the topic we are going to discuss in the further series. So first introduction, what is power electronics? Power electronics converters are used to uptime variable voltages. It is with an high efficient and ideally losses is less. So we have to convert the power electronics with using the variable voltages with high efficient and the losses minimum number of losses. So the type of converters used in is just depending on the voltages sources. And the AC voltage sources, the control is rectifier. If a fixed DC voltage sources, that is a DC to DC converter, that is switched mode power converters. So these are the some of the type of the converters. And to obtain the variable voltage sources from fixed DC sources and self-commutated device performed, that is the example for MOSFET, IGBT, GTO, and overthyrosis. These are the self-commutated drives. And next is commutated by low power control signal. And there's a commutation circuit is not needed. The commutation circuit is not needed. It can be switched at higher efficiency for same rating and improved motor performance. So motor performance can be improved by less ripple, no discontinuation current, and no increase in control bandwidth. It's suitable for high performance application. It is suitable for high performance application, and regenerative braking is possible up to very low speed, even when it's fed from fixed voltage DC voltage sources. These are the some of the introduction about chopper. Now coming to the discuss about step down chopper or class A chopper. So this is what step down or class A chopper. So this works in the motoring. We have four quadrant. We can see we have four quadrant. So this choppers work in quadrant 1, that is in motoring mode. Quadrant 1, it is in motoring mode. It provides positive output. Here we can see positive output voltage and current. Here we can see the voltage and current. So both are positive. The average power flows from source to load, and that is motor. The motor is considered. Here the average power, when the switch is closed, the power is flows from source to load. When the switch is opened periodically with the time period T, the switch is opened periodically with the time period T, what happens? This freewheeling diode takes place the actions. Okay, this when this process, this happens. Okay. So next is motoring mode. This motoring mode, when the switch S1 is on, here we can see here the two process, motoring process. When switch S1 is on, what happens? The supply flows from source to load, and when the switch is closed, what happens? With the help of freewheeling diode, we will be having continuous processing. So when switch 1 is on, VA equal to V. So armature voltage is equal to supply voltage. So armature current flows is, and the armature current IA get increases, and the duty interval is armature current gets increases. So this is the general voltage equation when it is on condition. Okay. And motoring mode, if the switch is off, what happens? The freewheeling diode process takes place. Here we can see the freewheeling diode process takes place when at that time the armature voltage gets 0, and the current flows through the freewheeling diode, and the IA decreases. Here what happens? The armature current IA get decreases. Here we can see the picture. The process takes place. Okay, this here the voltage, we know that we don't have the voltage, so the voltage is 0, and this is normal voltage equations. Here coming to the motoring mode, the duty cycles. Here comes to the duty cycles. So duty cycle is T on by T, whereas T is a chopper period. Here the on condition, when this when we get armature voltage, it is an on condition. When the switch is closed, it goes to the off condition. When the switch is closed, it goes to off condition. When the switch is on, it is in on conditions. So in this part, what happens? The freewheeling diode action takes place. Freewheeling diode action takes place. This part, the current get decreases. When the switch is on, the current get increases. Here with the chapter, we can see the formulas for duty cycles and for formula for armature current. This is about motoring mode, and for class A chopper motoring mode. When the switch is in on condition, it gets okay. When switch is in off condition, it gets close. Okay. So with this, we can end with this video. Another video we can see next. Thank you.